Hey, this is Mr. Beckstrom. Today I want to take a look at an example problem from section 7.1. This is on estimating a population proportion. So it says when she was 9 years of age, Emily Rosa did a science fair experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or her left hand, and then she asked the therapist to identify the selected hand by placing their hand just under Emily's hand without seeing it and without touching it. Among 280 trials, the touch therapists were correct 123 times based on the data and a close look at therapeutic touch. All right, so what she was doing was she flipped a coin and she either put it in her left hand or her right hand, and then she was asking them to the touch therapist to see if they could figure out which hand the coin was in. And out of the 280 trials, they were correct 123 times. So given that Emily used a coin toss to select either her right hand or her left hand, what proportion of correct responses would be expected if the touch therapist made random guesses? So that would just be what's the probability of just guessing randomly on a coin flip? So that would just be 1 out of 2 or 0.5. So A is just 1 out of 2, which is equal to 0.5, right? Turn this. All right, B. Use Emily's sample results. What is the best point estimate of the therapist's success rate? So remember what the point estimate is. We're trying to get the point estimate for the whole population of all therapists. And our best point estimate is going to be the sample. The point estimate from the sample that we've collected. The sample is the 280 trials that we did, and we had 123 successes out of that. So the sample statistic there, that's the proportion of the successes from our sample was what, 123 successes over 280 trials. 280 trials. So if we take a look at that, pull out our calculator, that's 123 successes divided by 280 trials. So our sample statistic, or our sample proportion in this case, is 0.439, so about 44% of the time they were right. So I'll put 0.439, 0.439. Right. And that's going to be our best guess for the entire population, because I don't have any other guesses for the entire population. So my best guess for the entire population is going to be the same guess for the sample that I just took. All right, the next thing it says, using Emily's sample results, construct a 99% confidence interval estimate of the proportion of correct responses made by the touch therapists. So this is around 44%. So now we want to construct some confidence interval, and we want to be 99% sure of our results. We want to say that 99% of the time that the actual true population proportion is going to be in this interval that we create around this 44%, right? So we want to create some interval where 44% is roughly in the middle, so maybe like 41 to 46 or 40 to 47, some interval where 99% of the time, that means 99 out of 100 times, that the actual population proportion, that means if we were to actually go and check every single therapist out there, every single touch therapist out there, and find the true percentage of how correct they were, that the true population proportion would actually be in our interval here. So in order to do that, we have a formula for it. So let's go ahead. I'm going to copy over the formulas and put them right here. Okay, so here's how we build our confidence interval here. So this right here, this is our true population proportion. That's the symbol for that. And then it's going to be somewhere less than our sample proportion plus our error. And we find our error by using this formula here. And it's going to be greater than our sample proportion minus that same error. So that's how we're going to build our interval there. And then, so over here, this is our Z alpha over 2. We get that by, depending on which confidence level that we use. Our three common ones are 90%, 95, and 99%. So here's the three values for those. If we use something else, the only other one that we will generally use is 98%. And they show you in the book the method for finding it. We can set up a curve and look at the area in the tail in order to find that. And we can look that up, or you can ask me and I'll do a little short video on that. And then the P hat and the Q hat, that's the sample proportion success and the sample proportion failure, and the N is the sample size. So let's go ahead and figure out this error here. So the error is equal to the Z alpha over 2. So this is a 99% confidence interval, so that's going to be 2.575. Okay. All right, times the square roots of P hat times Q hat. So P hat, we haven't actually figured that one out yet. So let's go ahead and figure that one out. So the sample proportion of success, that is just, actually we did figure that out right there. That's the 0.439. So that's going to go right here. So that's 0.439 times the failure proportion. So that's just going to be 1 minus that. So if I do my calculator, I do 1 minus that last answer there. So that's 0.561, 0.561, all over our sample size, which in this case is 280. All right. So last time I did this separately. First I did this product, and then I did the division, and then I took the square root of that answer, and then I did this product here. This time I'm going to do it all in one step because I'm using a graphic calculator, which we should all have. So I'm going to do 2.575 times the second square root of, I'm going to put the whole top in parentheses, 0.439 times 0.561, close parentheses, divided by 280. So you can put it all under one if you want to. You just have to make sure that if you have to put these in parentheses there to make sure it does correct order of operations. So E is equal to 0.076. 0.076. All right, so what this means is that now I can set up my interval. So my true population proportion is somewhere less than my sample proportion, which was what, the 0.439 plus my error, 0.076. That was kind of a horrible 7 there, 76. And it's also going to be greater than that 0.439 minus that error, 0.0. I never give myself enough room there. right? So doing the math, this is going to be, let's see, 0.439 minus 0.076. So that's 0.363, 0.363, and 0.439 plus 0.076 is 0.515. 0.515. So we're saying that we're 99% confident that the true population proportion of these touch therapists that can correctly sense the correct hand is somewhere between about 36% and about 51%. That's actually a really large interval. So the reason that the interval is so large is because we are using such a high degree of confidence that we need to allow for so many values. All right, so what do the results suggest about the ability of touch therapists to select the correct hand by sensing an energy field? It doesn't suggest that they're very accurate at it, right? Because if anybody has a 50% chance to do it, at the very best, they're at like a 51% chance, right? At the very best. So the results from this show that they probably don't have much ability to sense energy fields. That's kind of what this science experiment here shows. Now, the last thing I want to do is I want to use my calculator to also get this interval, although it won't be exactly the same just because they never are, but both of these intervals will be correct if you were doing a test or a homework. So we can also use stat, go over to tests, and for this one you can do prop z int. All right, so our x, that's the number of successes, was 123 because that was the number of times they got it right in this case. The n, the sample was the sample size was 280. We had a 99% confidence level, and calculate, and 0.363. Yep, they got that one right on the head, and 0.516. That was close. It was within 1,000th of ours. So much quicker to use the calculator here, but comes out to just about the same answer. All right. If you have any questions, please let me know. And next time I'll try to do a question on the next part of this section where it says if we want to be within a certain percentage, how large do we need to make our sample size? And that's a question that the group sometimes ask as well, because if they want to be if they want to have a certain confidence level to be within a certain percentage, then sometimes they need to ask a certain amount of people in order to be that have that high a degree of confidence. All right, hope y'all have a great rest of your week, and we'll see you soon. Thanks.